1.4, presenting scientific data. Scientists can organize their data by using data tables and graphs. Data tables. The simplest way to organize data is to present them in a table. This table relates two variables, a manipulated variable, which would be the location, and a responding variable, which would be the average annual precipitation. A line graph is useful for showing changes that occur in related variables or variables that show a continuous change. In a line graph, the manipulated variable is generally plotted on the horizontal or x-axis. The responding variable is plotted on the vertical or y-axis of the graph. Sometimes the data points in a graph yield a straight line on a line graph, and when that's the case, we can look at the slope of the line. Slope is rise over run. It's the ratio of the vertical change to the horizontal change. And we can calculate slope by doing rise divided by run. So an example of this would be the rise, it's going up 5 grams for every 5 grams horizontally. You can look at rise over run by just looking at the data points. And so this one is at 2 divided by 2, and that's how you can calculate slope. A direct proportion in a line graph is a relationship in which the ratio of two variables is constant. The relationship between mass and volume of water in that last graph we looked at is an example of a direct proportion. A 3 cubic centimeter sample of water has a mass of 3 grams. A 6 cubic centimeter sample has a mass of 6 grams, and so on. We can look at direct proportions and use them to predict beyond what the line graph shows. This is a graph, and so looking at this graph, it does not have a straight line, it has a curved line. And so this is a graph that shows the flow rate of a water faucet, how it affects the time required to fill a 1 gallon pot. So basically, if you have your water faucet turned on just a little bit, that's going to be this side. It's going to take a while to fill that pot up. If you turn that faucet on full blast, that will be over here on this side. It's going to fill up the pot in a lot less time. This is an example of an inverse proportion where the product of two variables is constant. And so inverse just means as one thing goes up, the other thing goes down. So as we, if a flow rate is 0.5 gallons per minute, then the pot would fill up in 2 minutes. If we increase the flow rate, the time will go down. So one last thing about line graphs is that we use line graphs to show continuous change. And so anytime that time is a variable, if we're showing anything happening over a certain amount of time, you're going to show that with a line graph. Okay. The next type of graph is a bar graph, and we use bar graphs to compare sets of measurements, amounts, or changes. So back to the data table we saw on like the second slide, average annual precipitation for different cities. We can show that because it's a set of data, and we can show that using a bar graph. Now look at the benefit. So here we could look at the numbers, and there's not too many numbers, so we could pretty quickly go through and see which city has the highest amount of precipitation. But if we look at the bar graph, we can just see which bar is the highest, which bar is the lowest, which one's in the middle. And it's a much more visual, and it happens a lot faster. You can read that graph and get information much more quickly. Another type of graph is a circle graph. This type of graph has many different names. So circle graph, pie chart, pie graph, all of those mean the same thing. But if you think of cutting a pie into pieces, you could have a mental picture of what a circle graph is. A circle graph shows how a part or share of something or a percent of something relates to the whole amount. And so if you're talking about a percentage of something, then you can show that with a circle graph or pie chart. I usually call them a pie chart. This one is showing the composition of Earth's crust. Again, circle graph is much better than just a list of numbers because I can see Oxygen is most of the Earth's crust, 46.6%. Scientists can communicate results by writing in scientific journals or speaking at conferences. And so scientists are always trying to gather new information, make new discoveries, and they want to share that because those discoveries could be beneficial to other people. Scientists also exchange information through conversations, emails, and websites. Young scientists, like yourselves, could also present research at science fairs. Peer review is a process in which scientists examine other scientists' work. You probably do peer review in your English classes where you write a paper, a peer of yours, another student might go through and look at your paper and give you suggestions about how to make it better. Scientists do that too. Peer review encourages comments, suggestions, questions, and criticism from other scientists. So maybe I do an experiment, I make a report about it, I send it out to other scientists to look at, and they give me some suggestions about how to make it better or questions that they might have about my study. Based on their peers' responses, the scientists who submitted their work for review can then reevaluate how to best interpret their data.